Let's solve this implicit differentiation problem step by step. We'll find dy dx given that y equals sine of x plus y squared. Let's start by differentiating both sides with respect to x. Remember, since y is a function of x, we need to use the chain rule. When we differentiate sine of x plus y squared, we get cosine of x plus y squared times 2 times x plus y times the derivative of what's inside, which is 1 plus dy dx. Next, let's distribute the terms. 2x plus y times cosine squared times 1 plus 2x plus y times cosine squared times dy dx. Now let's get all terms with dy dx on one side and all other terms on the other side. Subtract 2x plus y times cosine squared times dy dx from both sides. Now we can solve for dy dx. Divide both sides by the coefficient of dy dx. We can simplify this further using the trigonometric identity cosine squared equals 1 minus sine squared. This gives us 2x plus y times the square root of 1 minus sine squared of x plus y squared, all over 1 minus 2x plus y times that same square root. Finally, remember that y equals sine of x plus y squared from our original equation. So we can substitute y for sine of x plus y squared, giving us our final answer. 2x plus y times the square root of 1 minus y squared, all over 1 minus 2x plus y times the square root of 1 minus y squared. And that's how we find dy dx using implicit differentiation. Remember to use the chain rule when differentiating composite functions and keep track of all your terms carefully